The Egyptians had a base 10 system of hieroglyphs for numerals. By this we mean that they have separate symbols for 1 unit, 10, 100, 1000, 10,000, 100, and 1 million. The places or position of the numbers are based on powers of 10. Each number is 10 times the value to the right of it, hence the term base 10. Exceeding the number 9 in a position starts counting in the next highest position.
The oldest mathematical text from ancient Egypt discovered so far is called the Moscow Papyrus, which dates from the Egyptian Middle Kingdom around 2000 to 1800 BC. The pharaoh's surveyors used measurements based on body parts. So, for example, a palm was the width of a hand, etc., to measure land and buildings very early in Egyptian history. The papyrus is the first document found by archaeologists that contained the numeric symbols that the Egyptians used at the time. Here is a representation of the numbers to the corresponding symbols. So a bar represents 1, a horseshoe represents 10, a rope represents 100, a water lily, which was common to the area at the time, represents 1,000, a finger is 10,000, a frog from a metamorphosis of a tadpole is 100,000, and the Egyptian god He, or the god of infinity, is 1 million. As you can see to the left, there's a slightly more detailed description of the symbols. So for example, 1 bar would equal 1, 2 bars would equal 2, etc. Same with the horseshoes. So 1 horseshoe is 10, 2 horseshoes is 20, 3 horseshoes is 30, etc. And to the 100s place, you got the rope. The 1000s place, you got the water lily, etc.
So in Egyptian, we have symbols for every 10 to the power, starting at 0. So for example, we have 10 to the 0, which is a bar, 10 to the first power, which is the horseshoe, and so on. So to represent 34, we need 3 horseshoes and 4 bars. 67 needs 6 horseshoes and 7 bars. So to add them, we bring all of that down, and then we take the bars, since we have 11 of them, we're going to change 10 of them to a horseshoe, and then from there we have 10 horseshoes. So we change 10 of the horseshoes to a rope. Now we have rope and we have a bar, so that equals 101. For 420 minus 35, we're going to change them into 4 ropes and 2 horseshoes, and then 3 horseshoes and 5 bars. To subtract them, we need to take 420, and we're going to change one of the ropes into 10 horseshoes and one of the horseshoes into 10 bars. When we subtract them, we take the 11 bars minus 3 of the horseshoe, or the 11 horseshoes minus 3 of the horseshoes, and we have 8 horseshoes. And then we take these 5 bars and subtract them from the 10 bars we have up here. And that leaves us with 385, or 3 ropes, 8 horseshoes, and 5 bars.
So I'm going to be teaching you guys the Egyptian method for multiplication. So in this example, I'm going to show you guys how to multiply 31 and 12. Egyptians, they separate the 2 numbers in columns. So it doesn't matter which number goes into which column, but this is how you set it up. So for the first column, you start with the 1 and then you keep on doubling it until you exceed the top number. So in this case, if you were to double it again, then it would be 32, which is greater than 31. So you would stop at 16. So for the second column, you would start with this number at the top and then double it. So notice how I start with the 12 again, and then I do how many times I did the first column. So in this case, I did it 5 times, so I'm going to double it 5 numbers. So for this step, you have to, once you find the 2 columns, you have to find the combination of the first column numbers that add up to your top number. Once you find the combination that add up to your top number, then you have to add up the corresponding column 2 numbers that you found in the first column. So in this case, it's all the numbers. So 12, 24, 48, 96, 192. You would add all those up, resulting in 372. So I'm going to teach you guys the Egyptian method for division now. So just like multiplication, you're going to have to split up the two numbers in two columns. However, it does matter which number you put in each column. The bigger number has to be in the first column. That's the only priority. So in division, you would start off constructing your second column. So just like multiplication, you would start out with the top number and then keep on doubling. However, you'd stop until the number will exceed the first column number, which 208, if you were to double it again, it would exceed 325. So once you got your second column, to construct your first column is easy. You start with 1 and then you keep on doubling until how many times you double the second column. So in this case, it would be 5 times again, and then you would stop at 16. Once you find both columns, then you have to look at your second column in this case and look for the combination of numbers that add up to your first column number. Once you find out the combination, in this case, it's 13, 104, and 208 that add up to 325. And then you have to add up the corresponding numbers in the first column. So in this case, it's 1, 8, 16, and then your answer is 25.
That's a rack, no strings attached. That's a rack, no strings attached.